All right, welcome to the last talk for TRiRODS, August 2025. This is Samir Khan, another intern working on adding PAM Interactive to the Python iRODS clients. We've got in other places, and he was able to add it to the Python library. Take it away, Samir.
Thanks, Taro. As you said, I'll be covering PAM interactive authentication for the Python iRODS client or PRC. Before I begin, a little about myself. I'm a second-year computer science student at Georgia Tech, and I'm specializing in artificial intelligence and machine learning. And I'm especially interested in applying AI into healthcare and other impactful domains. And when I'm not working on projects, I like to travel and stay active at the gym. To start, I'll cover the PAM flow in iRODS. So the first step in the PAM flow for iRODS is the client starting the authentication by sending a RODS API request message. And this essentially creates that handshake between the client and the server. Once this occurs, the server then replies with a JSON message that includes a next operation field telling the client what to do next, and also any other information that the client would need. The client then updates its persistent state or P state, which essentially holds any important information needed for the entire authentication flow. So this could include like the user's username. Um, Once the client updates the P state and does what it needs to do, it then does the same thing as the server and sends a packet with a next operation field telling what the server to do next. And this sort of back and forth continues with the server guiding each step until the user is authenticated or some sort of error occurs. And this can be seen on the image on the left. Let's say the authentication is successful. The client will then create a temporary, or the server will create a temporary password and send that to the client, and this will be stored to use within the native authentication scheme. So from native to PAM, currently there's three different ways of authenticating with the iRODS server. The first one is the native authentication method, and this is a standard username and password flow. It is a single step and it's mostly client driven. We also have PAM password, which uses PAM but is still a single step, essentially mimicking the native authentication. And this does not allow for complex flows. And then lastly, we have PAM Interactive, and this is a server-driven, multi-step, and stateful process. And this allows for more complex authentication flows like multi-factor authentication. And currently, this is implemented in C++ for the iRODS client through the PAM Interactive plugin. And the goal of my project was to bring this to the Python iRODS client. So the project at a first glance, most of my past experience with authentication systems was abstracted away through systems like Firebase, and these systems don't really expose the underlying protocol of how authentication works. So this project really challenged me to go beyond that and required a deeper understanding of how you authenticate a user, for example. So to go over my environment and initial setup, I had a local iRODS server with the PAM Interactive plugin enabled, and I was able to use ngrep to look at the packet structures being sent between the client and the server. And this essentially became the baseline for what the Python implementation needed to replicate. I also went through the C++ client plugin code, and I looked at one method at a time to exactly understand what the steps were for the flow. And I was able to find that the flow is mainly driven by the persistent P state, holding important information, the next operation key guiding each step and what the client and server need to do next, and then also JSON patch instructions to update the state management. So looking under the hood, we have essentially six different categories of what each step is doing. The first category is the entry point, and that consists of the login method. And this essentially starts the authentication process, making that handshake and also initializing the P state and any other information that's needed. We also have the core flow logic, and these methods essentially handle the client and server talking to each other. So uh, essentially, the packets are sent through these methods. We also have state management, so anything that requires updating the P state or retrieving a value from there is done through these methods. We also have user input, so we have waiting and waiting password, and then get input. So the difference is essentially waiting is for any regular information needed from the user, then waiting password is more secure. So in the terminal, for example, when they type their password, it's not visible. And then we also have authentication completion. So when the user is able to provide correct information and everything works, these methods are run and allow access to the iRODS server. And then we also have failure handling. So anything with errors, timeouts, or not being authenticated due to incorrect validation is handled through there. So once I was able to implement this protocol in Python, I moved on to testing. And my testing strategy can be broken apart into three categories. The first one is integration tests. So these were run against a live iRODS server and covered full flows. So for example, successful login with valid credentials, failed login with invalid credentials, and then also a native auth shortcut using the .irods.a file. And what this allows you to do is there's a method that creates a .irods.a file, and that essentially stores the auth token that is sent by the server. So let's say you want to log in another time, you don't actually have to go through the entire flow again, and you can use that token. And then the forced password prompt behavior essentially bypasses this. So let's say you do have a auth token and you force the password prompt, this will still make you go through the flow instead of using the token. Then we also had some unit tests. So these were isolated testing of helpers, such as the pat state, retrieve entry, and then the get default value methods. And then we also covered some edge cases throughout those. And then lastly, we had the multi-factor authentication simulation. So this essentially mocked the server to simulate a multi-step two-password handshake instead of just a single password. And this validated the state machine's ability to handle complex flows without actually modifying the server configuration. This test could, however, be more robust by configuring a server that actually implements multi-factor authentication. So to go over how to use it, the first method is creating a iRODS session object and passing in the following parameters, and then also specifying the authentication scheme as PAM interactive. And then, for example, we are accessing the home collection, and this triggers the authentication. You can also create the auth file through the write PAM interactive iRODS.a file, and this essentially goes through the login process and then stores the authentication token. And then let's say you use the session object, this will auto detect that auth token and then use that instead of prompting you for a password every time. And then lastly, we have the option to force the interactive flow, and that is done through that method. And I'll quickly go over how to use this with a quick demo. Okay, so this is the first demo. So this is just the simple session object creation. We have a simple iRODS session object. We're specifying PAM interactive, and then we're going to access the home collection. So if I run this, you'll see I'm asked for the password, and when I'm typing, it's not being shown because it is a password field. So when I click enter, let's try that again. I think I might have typed it. Yep, I typed in the wrong password. So that shows what happens when you type the incorrect password. So this is how it should appear. So you can see the home collection was accessed. So now moving on to the second demo, now we'll create a iRODS.a file, and this will essentially allow us to use the token instead of going through the process again. So I'll run demo 2. So I'm asked for the password. I'll type that in. As you can see, the iRODS.a file was written, and then we were able to access the home collection. But let's say I don't want to use the iRODS.a token or file, and I want to force the password prompt. So I can enable that. Run this again. So I'll type in password. And as you can see, I'm asked for the password again since I was forcing the password prompt. So if I type this in again, I'm still able to access the home collection. And now lastly, this essentially shows how a multi-factor authentication flow would work. This is not actually enabled currently, but this is just to show what it would look like from the client perspective. So if I run this, first I'm asked for the password, I'll type that in. And then, for example, I have a question asking the favorite color. So mine is blue, so I'll type that in, and I'm able to access it. So once again, this is not actually enabled currently, but this is how it would look like for the client. Now I'll go back to my presentation. Right. So to go over some key takeaways, the first one was understanding unfamiliar code. So I was able to learn how to go through a large code base, and especially things that I had no clue of before. And I was able to do that by breaking it down into smaller chunks and focusing on what I truly needed for my project, and then experimenting with that code to figure out the things and understand anything that I had questions with and, ask questions about that. And that leads into asking the right questions. So through daily stand-ups, I was able to get better at explaining any blockers and asking the questions when I was stuck. So I avoid going through something that someone else has been through before and has more experience dealing with. So for example, Corey was able to help me set up a custom server to analyze the packet structures between the client and server, and that was crucial for my daily development process, and that served as like the baseline for what I wanted to replicate with Python. And then I was able to improve my code through code review as well. Feedback taught me how to write cleaner and more readable code, and how important it was to look out for small details for others reading my work that might not have the exact background regarding what I was working on. And that also leads into writing better documentation. So I was able to look at my code and truly understand what the prerequisites were to understand it, and write important and detailed documentation so both users and also future developers can maintain the code and have minimal issues when they interact with it. So in conclusion, PAM Interactive will soon be fully supported in the Python iRODS client. And the next steps are to finish the peer review process and then rebase and release. I just want to take a quick moment to thank Terrell, Corey, and the iRODS team for this opportunity. I've learned a lot throughout the summer, and I'm looking forward to how I can apply that in the future. So thanks again.
Thanks, Samir. That was great. I think you did a great job explaining how you got from A to B. I would like to know, you talked about having been on the other side of authentication and not really, not having to deal with the protocol itself. And you were pretty sophisticated Python developer already. Did you learn any Python while you were here, or is it mostly about the authentication? Obviously, iRODS, which is something you hadn't seen before.
I definitely learned a lot more about Python. I'd say the main area I learned the most about was testing and, for example, the unit test library. So I had done testing in Java before, but nothing with Python. So I think going through that process was definitely a great learning experience. I was able to learn a few tricks on how to automate some of the testing and make it more readable and also concise. So I think that was a great learning experience for discovering more about Python.
Yeah, that's really important. As soon as you want to refactor something, having a safety net is it's kind of impossible to work without it. I was also really happy to see that you said that explaining your work every day. I do think that all three of you got better at it. All three of you got better at it. I think that's an extremely important perspective and takeaway, because I think being able to scope your explanations and ask for help is the sign of a more sophisticated developer as well. So that's good. That's not a question. That was more just thanks. Does anybody have a question for Samir?
Yes, I have one. What did you find to be the most enjoyable part of this experience? It could be, yeah, just what did you find to be the most enjoyable slash surprising part? Yes.
I think I would say in general the peer review process. So I was initially expecting, uploading my code and then having some comments and taking care of some problems, but I quickly realized it's not, that simple, although it can be sometimes. But I think going through the peer review process, looking at comments, and checking off things one by one was definitely rewarding, and also allowed me to critically think about what I was writing. So having that outside feedback was definitely something I found enjoyable and also rewarding as I worked through it.
Excellent. Really
Yeah,
like that answer.
Yeah, and I hope that sticks with you as you start to review other people's code. There's a way to do it nicely, and there's a way to do it not nicely. So hopefully,
Right.
you got the nice version. Excellent. Anybody else? All right. Well, thank you, Samir. It was a pleasure, and I'm very excited that this will be merged and on people's computers pretty soon. Hope that's not too scary. All right. Thanks a lot.